Oh, okay. Am I recording? Okay. I am now recording. Okay. And so for those of you watching on Zoom, okay, like if you want to see this video and future videos, okay, ensure that those questionnaire responses hits at least 20, or else I will not release any more future YouTube videos. And also, I hate to be the bad cop, but I think it's like embarrassing, okay, compared to last year's group. Okay, there's like twice as many of you, and yet the number of people willing to write like a short thank you message on these kudo boards for these like mighty fine individuals is like anemic. Okay. At this point, last year we had three times the respondent, and now, we only have like 10. I'm not doing this like for my health, okay? But I really, really firmly believe in gratitude, okay? And so this year we have 20,000 students, and the amount of like YouTube video viewing is like 4 to 5 times as much. And so unless, each of you is just like looking at the video multiple times, okay, I mean, which is fine, which is possible, okay, I expect, this kudo board number to go up again this week. So unless I see both of these go up, okay, you will not see the YouTube video. I know the YouTube video is like highly desirable because every week they get like hundreds of hits. So if you want to like listen to Chris, you want to listen to like Beliakoff pontificate on coding, okay, just like go fill out the form now. Like, just leave like a short note of gratitude. In fact, none of these kudo boards are even for me. Okay. It's not like, I need love and encouragement. They're all for other people. Okay. In fact, like Belyakov needs a lot of encouragement. And so it's mainly for him. Okay. Okay. So, that's all I'm going to say. And so just fast forward to the next couple of weeks. Okay. Chris is doing week 7. Next Friday, we're doing like a 2D list, and then Chris will be back. And then Alex is going to talk about strings, and then Emma is going to talk about APIs. I know some of you guys commented it would be really helpful if we had like a link or like an email opt-in, opt-out. Actually, last year we had an email list. Okay. But that was a lot of work to maintain, which is why I didn't do the email list this year because I had to collect everyone's email, put them in a spreadsheet, and like email everyone. And so just please like check this forum pin post every week. Um, and, I would love to be able to pin every single post, but as some of I had to like bug Cameron Monet like umpty number of times and then nearly gets into spat like umpty number of times just to post, to pin this one post. Okay. And so I went to bat for you guys. And so, I hope you guys will like check this master post. Okay. Okay, and then just three other things, and I will stop talking. Okay, so I'm getting a little bit bored of just doing like Amazon gift certificates, $5 each week. So next week, probably for 2 or 3 weeks, okay, I actually signed up for one of those like Zappo or Zap, whatever free shipping thingies. Okay, and so for the next 2 or 3 weeks, okay, our geography quiz is going to be really, really hard. And just to make things interesting, okay, like no one except me will know where these places are. And so section leaders, you can participate too, okay? And so for the next 2 to 3 weeks, I will be raffling a free SIP 2025 t-shirt if you want, okay? Or the equivalent in an Amazon gift certificate if that's what you would prefer, okay? And so if you want to like wear one of those like SIP 2025 t-shirts, okay, like study up your geography, come to Zoom section for the next like 2 to 3 weeks. And then also one thing we've been talking about to try to make the learning better for you guys, is, Emma and Dieter have gratefully considered offering office hours, okay, because we know the material is getting harder and, not everybody, um, could do all of the problems on their own. And like we know CS 106A does have office hours. So we haven't actually ironed out the details yet. But hopefully within the next week, we'll have more details coming. So just keep an eye out on the forum. It'll probably be offered um, like Zoom, but not quite like the campfire where they go on for 4 to 8 hours because we don't have the bandwidth. Okay. It'll probably be like a 1 hour at most. Okay. Um, we're not gonna record it. It will be a safe space, but I don't think any of us have the bandwidth to like stay for 4 to 6 hours. Lastly, I do want to share something. So allow me to change the screen one last time. Um, because everything we're covering now is relatively new material, okay? Um, every week, before the section, I will upload a folder of materials to the Google Drive, okay? Um, and within this folder, there will be slides, okay? The slides do not have voice. And so um, basically, they are slides from the spring CS 106A course that's taught by Maron. And then there will be something called a video that's in the MP4 format, okay? This is me trying to be Maron. Okay, so obviously I'm not as eloquent, I'm not as articulate, but hopefully I'm slightly better looking. And so this is me narrating over Maron's slides. Okay, because last year I found just looking at these blank lectures without any explanation to be very difficult sometimes because I can't get inside his head. And so we would really encourage you to look at these lecture and the narrative videos before coming to section so you have some idea the concepts that we're going to talk about. I think Alex will still make his like summary slides, but I think the material is getting hard enough that it would be very hard if you're just relying on Alex's summary slides without any background. And then also within this folder, there will be an assignment. Okay. So the assignment shows the problems we're going to go over. Usually there is an easy problem that's like what, like sandcastle, and then there's like a harder problem that's like sand. Okay. So you should try to attempt these problems if you can. And that's what we're hoping the office hours will be helpful for so that if you have questions, you can go pick Emma and Dieter's brain, but you don't have to have the problem solved before coming here because then you'll just be sitting for 2 hours listening to Belyakov pontificate in his Russian accent, which may or may not be all that useful. Um, but we would encourage you to at least look at these things, okay? And lastly, within this folder, there will be files that ends in this .py. This is usually a starter code that can be run in either PyCharm or VS Code, okay? And so this provides a starter code for you to actually do your program because these programs are sufficiently complicated, they won't run in the SIP IDE, okay? So you do need an external IDE. And also, when you are here in the session, okay, if you want to code along with Alex, okay, you could open these files and then code along with them. So I just wanted to explain how to use these folders and definitely reach out on the forum if you guys have any questions. And so with that, I will stop babbling and turn it over to Chris. Sorry to take your time, Chris, but I do expect to see an uptick in both the questionnaires and the Kudo board. Okay, I'm gonna be like very furious if I don't.
Cool. Thanks so much for all the announcements and the introduction. And no worries about taking the time. I think today's session should work out timing wise, even with a bit of a late start. So all good on that. To preface, I want to give an overview of what I'm planning on covering today. So the remaining of the two topics before our like more hands-on projects are going to be pandas and matplotlib. Pandas is kind of like a step up from NumPy, where we're kind of creating these like explicit tables where um, like our dimensions have names, and you'll see what that means when we start going through that. And then Matplotlib is super useful to just visualize data. So we can actually create graphs like right within the Jupyter Notebook. So I'm thinking of spending maybe the first uh, hour or so going over pandas, and then the remaining time for Matplotlib. Again, I'll be going through like the data science handbook that we used last session on NumPy. Um, and yeah, with that, we should be able to get started. Um, so let me share my screen. So I started up my Jupyter Notebook. If y'all want to follow along, I would suggest starting up the Jupyter Notebook as well. To remind, as a reminder, I think for Mac OS and Linux, you can open the Terminal app and just type in Jupyter Notebook, and that should launch that web page. For Windows, I believe we have the Anaconda. Um, I forget exactly what the application is called, like the Anaconda launcher or Anaconda something. If someone could remind me, but yes, Navigator. So if you could open that and just launch Jupyter Notebook, we should be able to reach a screen that looks something like this. And then we can just go into Notebooks V1 directory, and there's all these chapters. Um, so we can jump right to chapter 3, Introduction to Pandas, and that'll take us here. I'll give everyone a couple minutes just to get that set up and opened up for those of you who are interested in running through it along with me. And for anyone who's already ready, this is like a pretty short chapter, just kind of introduction. So feel free to just run through some of the cells. Make sure you have pandas installed. So this first one cell checks that you have the version, and the second one imports it. Um, and if you don't have it, I believe you can just run um, a pip install. So I can type the command, some variation of this.
Hey,
So
Chris, I have a
yeah.
quick question, okay? For all of these, if we don't run it in Jupyter Notebook, can we run it in like console or terminal?
Um, do you mean like the actual like cells, or like if you
Yeah,
copy the code, or
yeah, I mean, which means like if I don't open Jupyter Notebook, could I just type, import pandas and then like pandas dot whatever um within terminal?
yeah. So it's slightly like not directly within terminal, but I'm not sure if this was covered in code in place, but you can actually open like a Python interpreter where you can do essentially the same things. Um, this is first like the command that I use to install pandas in Matplotlib. It says a requirement already satisfied, so
Right.
that's installed for me. But you can also open like a Python interpreter. So you can't type like Python code right here. If you type like
Uh-huh.
import pandas as PD, it's not going to recognize that. But if you open up a Python interpreter and you type import pandas as PD, then it would recognize that.
Would a Python interpreter be like PyCharm, VS Code, or is it something different?
So an interpreter is slightly different from like PyCharm and VS Code. VS Code and PyCharm are IDEs, so they're used to like modify, like just write files and change them. An interpreter will actually run the code. So this is something like uh, I'm not sure if there are other examples, but you can just look up like, for example, you can probably look up like Python interpreter, and there's like online versions of it where you can just like type things in. Um, it's just a way to like run Python code. Um,
Okay.
so it's slightly different from an IDE, which is just used to edit code.
Okay. And then how do we know if we have a Python interpreter or not?
When you install Python, it should by default come with an interpreter.
Okay. And then sorry, one last question. What's the drawback or benefit of running it in an interpreter versus Jupyter Notebook?
Um, Interpreter is not generally used for like developing actual code. I'm not sure if there's like an official use for it, but in my experience, it's mostly been just to like test things out and make sure that like um I don't know, like syntax is correct, or if I want to validate like some weird specific like Python edge case, then I can like for example create like variables and I wanted to make sure like maybe a plus b is equal to like 5, then like I can run like line by line Python code just to like do some quick tests. But like as soon as I exit out of this, all that code is going to be lost. And then if I open it up again, like A is not going to be defined again, even though I defined it earlier. It doesn't store its state or anything. It's just kind of like a one-time um interpreter, like I don't know, like
My
environment or
understanding is that the Python interpreter comes when you download the language Python because your IDEs need the interpreter to understand what you're typing in the file. So it's kind of just like this thing that you can play with, but we typically don't because it's not going to save anything. So if you want to work on a project, you're going to want to do it in an IDE or a Jupyter Notebook so that you can store it. And then yeah, I think the only time I've ever used an interpreter alone is just when I want to double check that something works exactly how I want it to. Like in different languages, integer division works a little bit differently, and then I'll just like check to make sure that it's doing what I expect it to in Python. But yeah, that's kind of the only time I use this feature.
yeah, yeah. That's a great description of it. Thank you. Thanks so much for that.
Thank
But yeah,
you.
does that answer your
Hmm.
question?
Hmm.
Cool, cool. Um, yep. So going back, hopefully people have, oh, maybe share. Yeah, going back, hopefully people have gotten to their Jupyter notebook and have opened the Pandas chapter. So we'll go through a brief overview of what Pandas is and then run through some of the code, um, just as like a hands-on way of discovering like what Panda is capable of and what it's typically used for. Um, so here, like, there's a lot of words here. Essentially, like pandas, like data manipulation with pandas is kind of building off of what we learned from NumPy, and actually, in many ways, it's quite similar. It allows us to basically use some form of structured way to represent like large amounts of data. Um, there's, yeah, let's see. The primary things to remember from here are that we're going to be using something called like a series object within pandas as well as a data frame. Those are like kind of the main structures that we use with Panda. And then this kind of like integrates well with large existing data sets if you want to like download real data that's already in like a table format. You can pretty much convert that into like a data frame super easily. And we'll see in later chapters how to do that. But yeah, this first chapter is pretty There's pretty much not much content. Just make sure you have pandas installed, and then you're able to import it. And the convention here is importing it as PD. Um, just basically because people like to do that. Yeah. So moving on to the next chapter, introducing Panda objects. Um, we're essentially going to cover like so what I mentioned earlier was the series object, the data frame object, and then they also mentioned here like an index object, which is closely related to all of them. Um, so we'll just go through each one of these individually. I think this entire chapter has like a section on each of them.
Hey,
So
Chris, will you define
yeah,
what a data frame is and how that is different from an array?
yeah, we'll definitely get to it.
Okay, great.
This is in like yeah, so it'll go one by one. So this first chapter, first like sub chapter is like the pandas series object, and then we have like one for the data frame object. So yeah, don't worry, I'm not expecting you guys to know what it is just from like one mention of it. Um, so starting off, I think like. It will basically like build off of each other. So series is kind of like the most basic object within pandas. It's a one-dimensional array of indexed data. So here we're defining like a pandas series of just four numbers from like 0.25 to 1. And then when we run this cell, actually let me clear the output and then rerun. So when we run this cell, we can see that the data is represented like this, where we have like an index of 0, number 0.25 and so on, which is kind of similar to like an array or like a NumPy array that we've seen before. Um, so yeah, the series wraps a sequence of values and a sequence of indices, the indices being 0, 1, 2, 3, and the values being 0.25, zero point 0.5, 0.75, and 1. Um, and you can actually access them individually. So they're like attributes of this like Panda series. So we've defined our Panda series as like with a variable named data. So when we say data.values, we get the right-hand column, which are the values um, of the series. And then we can do data.index, which gives us the left-hand column, which is like the index. Here it's like represented kind of strangely, but if you think back to like Python range, it's defined as like start, stop, and step. So this is essentially just like 0 to 4, not including 4, with a step of 1. So 0, 1, 2, 3. And this is actually of type index, which is one of the data types, data structures within pandas that was mentioned here. And we'll go over it a little more in depth in that own section. Um, so yeah, that's kind of like what a series is. And you can also access it um, like an array. So data one accesses like the first index, and data one, two, three accesses one and two. So it gives us this. Um, but yeah, you can kind of so yeah, it this textbook compares the series object to like a one-dimensional NumPy array. And it's actually very similar to um, that, but it has like a couple more qualities that makes it like a little more versatile than just a regular one-dimensional NumPy array. Um, yeah, so here it looks like it's basically interchangeable, but the main difference is series can have an explicitly defined index. Um, and what that means is like I guess here we say like NumPy array has an implicitly defined integer index, which means like when we define a NumPy array, um, where that where each value is stored is kind of just uh, implied based on where in the array it exists. So like the first item is going to have an index of 0, and that's always the case for a NumPy array. Second is going to have an index of 1, and so on. Whereas the pandas series, you can actually explicitly define what each of the indexes mean. So instead of like the index consistently being like 0, 1, 2, and 3, you can define actual like different types of values for the index. So here, like you can see, we're doing a similar series definition as before, but now we're specifying a second argument, which is index, which is another array of, or another like list of four elements. So you can see that these will probably map one to one to each other. So now we have like our index column instead of 0, 1, 2, and 3, we have A, B, C, and D. And this is like the index column, and this is the value column. So we can actually access data according to the index, like that we see here, the same way we did it in this data square bracket one access. Um, yeah, and then I guess another confusing thing is you can actually use just like other numbers, which makes it look a little bit confusing. In I guess in this scenario, because now we have like 2, 5, 3, and 7 as our indices. So when we try to access data 5, it gives us like the second element. But this is essentially just to illustrate that Panda series can have like their own defined indices, which is how it differs from a NumPy array. But in other ways, it's like in other aspects, they're pretty similar. I think this is just like the main differentiating quality. So this next section talks about how like what we've basically described is like very similar to a Python dictionary, where like even the data access looks pretty similar. Um, I I'm guessing that dictionaries were covered in code in place, but feel free to stop me if not. Um, but you can see here that like we can actually like because they're represented so similarly, we can actually create a series object from a dictionary. So we're defining a dictionary here where I guess this is probably like landmass or population or something. Anyways, we can define like this dictionary which has some sort of meaning, and then when we convert that into a series, it follows like the same representation as we've seen before for a Panda series, where the left column is the indices and the right column is the are the values. Um, so yeah, and then similarly, we can access them in the same way. Um, so we can do population of California. Oh, population. I'm blind. Um, but yeah, by default, a series will be created where the index is drawn from the sorted keys. Um, so yeah, this
Hey Chris, there's a question
yeah,
in the chat. Does the
sorry. Yeah.
pandas array need to be all of the same data type? I thought the answer was no, but maybe I'm wrong.
I believe so. So you can also see here that like the data type is specified, at least for the value. So if we try to turn this into like, or let's see, let's just like turn this into a string.
Really?
Um,
Because I queried ChatGPT and then ChatGPT says no.
um, so I
I think
guess, yeah, go
that,
ahead.
sorry to interrupt you.
No, you're good.
I think that when it can hold things that are different types, and in those cases, it turns the type to object.
Yeah, so you can see
Generally, you
that's
would
what
want them to be the
happens
same
here.
type because then,
Yeah.
like, if they're the same type, you can use them and iterate through them in productive ways. And if they're all different, it might be harder. Yeah.
Yeah, it seems like it could be like um so like if we had maybe like one that was uh, like all numbers and then another one, if you wanted to like say like add them, then you couldn't do that if the first one was an object.
Well, um,
Yeah, it gets
what I thought happened is that at least in NumPy, if you had like different data types, it will try to convert them all to a same data type and then work with that. Kind of like
Mhm.
suppose you had string and then numbers, it will probably convert your number into a string and then and so everything becomes like a string or something like that.
Yeah, so that just made like in so that's true, and that still makes the like panda series or the numpy array like homogeneous
Hmm.
because it finds like the same data like a umbrella data type that it can use for
Right, right, right.
everything, and object just happens to be one that like anything can be represented as.
Hmm.
Um, but yeah, like it just makes it harder to perform um like numerical operations on it, for example. Like here you can see in this example, like when we try to add the populations together, but like if these are objects, then it like sums them as like strings. Um, so it just I guess like yeah, and then here the data type is still object as well. So like I guess everything was just grouped into the same data type because of this one string. But generally, we would
Got it.
probably want
Okay.
it to be like an integer so that we can like sum it
Yeah. Okay.
as we want.
All right.
So like the using the same or like finding like a homogeneous data type that all of the qualities can be used for is I guess a little more relevant when it comes to like using integers versus decimals. So if we like added like a decimal here, then it would convert everything into a decimal. Um, just so that we can have like the homogeneous type. Because a lot of the operations that are done on these types of objects are like vectorized or like basically um, they happen to like every single element of the array or of the series. So it just makes the most sense if they're all like the same type when you do that.
Okay. Thank you.
But yeah, good question. Um, oh, also I forgot to say population too, but you guys get the idea. Um, yeah. So same way you can access yeah, I guess going back, you can access this population series the same way that we were doing before, where instead of like, but now I guess instead of using a numerical um, index, we have like a string index. And then we can also do like like a slicing access as well that reads like, yeah, we can probably do like Florida as well to truncate Illinois. Um, yeah, so that's essentially like all there is about series. I guess there's this one more section that we can go over really quickly about like constructing series objects. Um, we've seen this before. This just creates like a series 246. Um, and then yeah, this just covers like some edge cases. I think like this will be something that you eventually bump into when you're like using pandas more practically. But we can just run through all of these. So when we pass in just a scalar to series, but we pass in like an index, this implies that we should have three elements, but we've only passed in one. So it guesses that we just want to use five for all three elements. Data can also be a dictionary, um, which index defaults to the sorted dictionary keys. So we saw this earlier with the population dictionary. And then we can also set index explicitly. Um, yeah, so I guess this just takes out like uh, B because we've only set indexes 3 and 2. So yeah, that's Panda's series. Before we go on to data frame, did anyone have any questions?
On the slicing, I think you showed it was
Mhm.
very quick. I know in with
Sorry.
lists, when we do a slice or in NumPy arrays, you have the highest index, but you're actually cutting only the one before that. Here it's inclusive, right? Is Illinois included here?
Yeah, that's a good point. It seems to be inclusive, actually. didn't know that off the top of my head, but like this is, I guess, also why Jupyter Notebook is useful because you can kind of just run like small snips of code. But yeah, that's a good catch. So um, slicing for series is inclusive. Uh, yeah, interesting. Yeah, thanks for pointing that out. Any other questions? Yeah, interesting because this is not inclusive, but when we have string indices, maybe it is inclusive. Let's do B to, oops, string must only work with dictionaries. Oops, never mind. Just live demo stuff. Yeah, so here it's inclusive as well. So it's interesting that it's different between numbers and strings. Yeah, any other questions? Cool. Let's move on to the data frame object. So this is something that's going to build off of the series object. So I think the I guess comparison that this textbook uses here is if we think of series as like a one-dimensional NumPy array, data frame is like a two-dimensional one. So again, like the special thing about these pandas objects is that you can specify like what the indexes mean, whereas in NumPy they're implied. So data frame just allows us to specify like the row indices and the column indices. Um, so yeah, I would say think of it as like a two-dimensional array. And you can see that like once we see how it gets represented, it looks pretty much uh, like a table, which yeah is a good way to represent data. Um, so yeah, let's go through some of these cells. So we have an area dictionary. This time it's landmass of these states. So we convert this dictionary into a series, and what that looks like is just a list of um, the state as the index and the actual area as the value. Um, so now that we have this along with the population series, we can use it to construct the two-dimensional data frame. So let's make sure that we have this defined. So run that again, and then yeah, let's create the states. So yeah, as you can see here, this is like the data frame that was created, and it's represented in like this nice table form, which is pretty easy to interpret as like someone who doesn't really know what like this looks like in the code, right? So yeah, it even like highlights when you hover over it, which is nice. So this data frame is basically created based on like we're defining these two columns. This is our like column index. And then we have each column is represented as like a series. So that's where like our second dimension comes from. Um, so yeah, now we have this table where we can see like the population and the area of each state. Um, and then similarly to before, we can run like states.index and states.column, which tells us like these are the rows and these are the columns. Um, Similarly to how series has like series.value and series.index. Um, but yeah, that's kind of what a data frame is. So we can go through like some more details about um, what attributes like a data frame has. So let's see. We run this. this axis is like the area column of the data frame. And you can see that just returns like the series object that we passed into it when we were creating it. So you'll notice that like a data frame is actually just storing like a bunch of different series values under each like individual column name. So it's again just like a two-dimensional version of like a series. We're storing like a series of series. Um, yeah. And then we can construct them in a bunch of different ways, similarly to how a series can be constructed in a bunch of different ways. Um, so you can have like a one dimension or like a two-dimensional data frame of just one column. So this gives us just like one column, but it's still represented as a table. So it's still a data frame, but it only consists of one series. Um, but you can also, again, like we saw earlier, have multiple series, like up to however many you want. But this is kind of like looks like a one-dimensional one, but we've essentially just labeled this series as a population series. You can also create a data frame from a list of dictionaries. So this syntax is a bit confusing since I think list comprehensions haven't been covered yet. Um, but essentially it's creating like three dictionaries where A is like uh the 0, 1, 2, 0, 1, and 2, and then B is like 2 times 0, 1, and 2. And you can see how that gets represented. So essentially we have like three dictionaries and then they get turned into like um this table. Um, so like I guess to better represent that, if we show data, um, we can see that it's like three dictionaries. And then what was it? PD dot data frame. Now we can show that. We can also just print data. It'll show both. Um, yeah, and then here you can see like the indices are not exactly the same. So we have A and B in this dictionary, B and C. Um, so when there's missing data, it will just fill it in with not a number. So that's what this means. And then, like we saw earlier, you can create you can create a data frame from series objects. Um, yeah, there's so many ways to create it, but you can kind of see like work through these yourselves, I think. Yeah, this is just like through a NumPy array, through structured array, all kinds of different ways to represent it. But the important thing is like to be able to get to a data frame because once we're at that point, we can do all of the operations that Pandas allows us to do on data frame, which is great because data frames are like a very versatile object. Um, so yeah, that's pretty short for a data frame, just because it builds basically directly off of what a series object is, which we spent a lot more time covering. So yeah, did anyone have any questions about the data frame object before we go on to the final like index object? Cool. If there aren't any other questions, then we'll cover the last important object within Pandas, which is the index object. And this has definitely been mentioned like quite a few times going over the other ones. Um, but I guess there's some like additional information to know about it. So yeah, we've talked about like the explicit index that you can set within like the series and data frame objects. Um, and it's essentially an immutable array, um, which is something like an array that can't be modified. And it's also like an ordered set where all the values have to be unique, and it also follows like a specific uh, order. So like you can't like it doesn't get rearranged. Like once it gets defined, it stays that way. So we can create an index from a Python list that we've seen before. And this will just, it looks pretty basic because we're essentially just wrapping it in like this index call. But when we see this, we know that it's like an index type and it has like the qualities of an index. So yeah, index is an immutable array. Array, like we're familiar with that and how to work with those. So like this is all familiar stuff. We can access values, we can do slicing, and we can print like a lot of different qualities of them. So essentially like a one-dimensional NumPy array. But the main thing is like you can't, since like it's immutable, you can't modify the value. So yeah, index does not support mutable operations. Um, and then we can skip over this. This is essentially just telling us like um, the like pandas object is like a ordered ordered set, and there's like a bunch of these operations that you can do on them. Um, yeah, or they're like similar to Python sets, but Python sets are not guaranteed to be ordered. Um, yeah, cool. Any questions about that entire chapter as a whole? If not, let's go to the next chapter, data indexing and selection. Um, so yeah, here we're going to be pulling like a lot of the topics that we covered from like data indexing and selection for NumPy arrays, because again, pandas series and data frame objects are pretty similar to those. So yeah, here it says like the corresponding patterns in pandas will feel very familiar, though there are a few quirks to be aware of. So yeah, let's start with uh, just running through these cells. So we're going to create like a panda series from two Python lists, one for the values and one for the indices. And then we've seen this, but we can access them based off of their indices. Um, we can also do certain things like check if A uh, is in our series. So A is in our series. This is similar to like Python dictionary, where this checks whether it's a key in the series. And then these are all like very familiar operations. Actually, let me clear the outputs. But yeah, these are all essentially really familiar um, functions for Python dictionaries. And you can also, yeah, modify series the same way you modify dictionaries. Um, yeah, so I mean, it seems like, yeah, this is saying it like seems very similar to dictionaries. So like the immediate question is why are we using it instead of dictionaries? But it's purely just like for convenience, and Pandas like does a lot of different things under the hood. Yeah, series as one-dimensional arrays. Um, so again, these are like slicing that we've seen before. Slicing by explicit index. So I guess this is what you were mentioning earlier, Dieter, about um, the, I guess, strings being explicit indices. So this is like included. But when we use integers, it's um, not included. I guess explicit and implicit are not the right adjectives for that. But you can see here that that's like a quality of the um, the indexing. There's also something called masking, which is pretty pretty interesting. So this looks confusing. I think we can maybe just remove one of them. So this is like uh, data is greater than 3. So actually, let's point 3. So we can like maybe build up to this one by one. But if we do like data is greater than 0.3, we'll see like this is what we call a mask, which is just the same array, but instead of the values being the actual values, it's like this Boolean. So you can see that this greater than 0.3 expression has been applied to every single value in our data. So if we look at data, you can see that it's like 0.25 all the way to 1.25. So then when we check greater than 0.3, it's only true for B through E. So now we can see that if we try to access data where data is greater than 0.3, then it should give us just B, C, D, and E, where these values are true. So it gives us those specific indexes and the corresponding values. So th this is essentially just like we're passing in a series as like an index to the series, if that makes sense. And then what we saw earlier here was like we have another I guess mask where instead of checking greater than 0.3, we're checking less than 0.8. And then this and will just give us like the combination of these two where like both are true. So you can see like we had true, 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 false, false, but for data greater than 0.3, we had false, true, 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 true. So the only overlap is B and C. So when we access data according to that, we'll just get B and C. Um, and then we have fancy indexing. So you can see that this just gives us like the specific columns that we selected. Um, yeah. So that way you don't like if you want like not connected indexes, then you can access it that way. Yep. And then there's a couple more things for indexing. So here we're creating like a new series where our indexes are 1, 3, 5, where the values are A, B, and C. So this is interesting because we're using explicit indices, but um, the numbers are, or the indexes are numbers. So when we do this, we have our explicit index. But then so yeah, data one is A, but when we index here, we get 1, 2, 3, implicit index when slicing. So yeah, this gives us like, you can think of it as um, like think of another column like 0, 1, 2, just next to 1, 3, 5, which is like the implicit index. Um, and we're accessing like according to those. But if we wanted to access them like based on the actual index that we've defined explicitly and not the implicit index, then we can use data.loc. So this gives us like the location of yeah indexes 1 to 3 based on like the actual index. Um, yeah, and then let's see. We can actually see like what the string is. I think if we do this, so yeah. Sorry, I'm just trying to see what it stands for. I think it stands for location. But yeah, you can again reminder that you can do docstring this way. Yeah, and then we have iloc, which is based on the implicit index. So you can like specify whether you want like this allows you to access the series like without ambiguity of whether or not you're using like the implicit or the explicit index. I think yeah. So just remember like LOC and ILOC. Um, okay, moving on to data selection in data frames. So graduating from series, let's create some data frames and play around with like the axes there. Uh, so here, when we access data of area, this is like basically asking for the columns. So like the order of access would be like, I guess, um, the column and then the rows, because this gives us the series, and then we can access the individual row of the series, like after that. Yeah. So for example, if we like now that we have data, we know data area corresponds to the series. We want like the area of California. We can access it this way. Gives us that integer. Another way to access it is just by dot notation. Um, and yeah, this just shows that it's the exact same object, rather than copies of it. Um, yeah, this is, I think this is like, uh, we can probably skip over this, but I guess now that we're here, I'll talk a little bit about it. Um, but like the difference here being data.area is equivalent to data like square bracket area is different from data dot pop, because I guess pop is like a method within data frame. Um, so like this is corresponds to a function and not like I guess if we do this, it gives us like a method. So we can actually see like a doc string for that method. Um, so there's just like that ambiguity because there's like two things that we would want pop to point to. So then here we would have to access it based on a square bracket. Um, yeah, I think that's why it says you want to avoid the temptation of accessing um, using the dot notation instead of the square bracket notation. Yeah, and then you can also do modifications to it. So you can create a new column. So here, like we have density, which is just dividing one series by the other series, which is nice because it does it for the entire column. So this is like another cool thing that Pandas data frames can do. Um, yeah, and then you can skip over some of these. It's not indexing conventions. Yeah. It's a weird interface, but that's pretty much it for indexing and selection. I think that's covered like most of the important ways that you can access things. Um, and I think that's just like enough to know for indexing because it does get like kind of confusing, and I think um, it's important just to know like the fundamental ways to access things, and that should be enough. Um, but yeah, did anyone have any questions about data indexing for series or data frames from this chapter?
Hey Chris, are you going to talk about how Pandas deals with like missing data?
Yes, that is covered.
Okay, cool.
Just where would you recommend kind of starter exercises with this? I mean, this is good reference. I can work
Yeah.
through this, but gosh,
No,
I'm
I
gonna
totally understand.
to
It's just
kind
like
of
a lot of information, right?
baby me through an
Yeah.
example. I was trying to see if the CS106A had any um, pandas.
No,
I don't think it
unfortunately,
does.
Martha, no.
Okay.
Um, this is just like extra things that I kind of wanted to
Oh
learn
yeah,
to
yeah,
help.
yeah.
Yeah,
No,
so
I I'm I'm really grateful that I did not try to use this for my final project, which was like, oh, well, I need to do work with some tables of data. So, but yeah, any pointers from section leaders on good places that have just like a here's an exercise, and maybe it's just working through these exercises and this material in Jupyter, but in an IDE is what I'll want to do to start, because Jupyter still breaks my brain a little bit, so I need to I'll work on the IDE. But yeah, if you've got any hints on like here's a good example, um, I would love that.
Yeah, I don't have any off the top of my head, but if
It's
section
more maybe
leaders,
more the section leaders, and this is
yeah,
something
yeah, yeah.
to take offline.
Yeah, no, I think that's definitely a great question though, because this sort of content is, yeah, like you said, a great reference material. But really, the most of the learning comes from actually like playing with uh, these libraries and like kind of like playing with just writing code in them.
Yeah. Yeah.
I would say like Jupyter Notebook is valuable in this case because it's much easier to run code in Jupyter Notebook than it is in like an IDE, where like every time you run the code, you have to run all of the code that you wrote. Um,
Point.
but yeah, here like you can like run basically just like one-off like parts of the code. So like when we run data pop
Right, right. And
or
it's easier to read than like trying to figure out what the heck the debugger is doing.
yeah, exactly. So I would recommend sticking with Jupyter Notebook if you can. And then in terms of like
I'm sure
figuring
there
out
are
like
exercises out there. I'll share with Vicky
yeah,
if I find a good
there's
one
definitely
that I
exercise
like.
there's a lot of yeah, there's a lot of things out there, I'm sure. I just don't have anything off the top of my head. Maybe like the section leaders do, but I think it
Um,
is valuable. Yeah,
Chris,
go ahead.
I thought for next session you were gonna go through a case study, right?
Oh, right,
Yeah,
right, right. That's coming up. Yes. Okay.
yeah.
Good, 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 good.
So, I would
Thanks, Vicky.
like, I think there are definitely smaller scale things. So that's one thing which I was hoping would reinforce like some of the stuff that's being covered in like this uh more like reference style like textbook thing. But I think there are also smaller scale things out there where it's like maybe like work like exercises that you can practice your panda skills by just like them giving you like the data and them asking you to do something, and then just trying to like conform the data or like the data frame into something that like the exercise is asking you to.
Yeah, yeah. This is
Kind
this
of
is
just
this
like,
is great. It's giving me a Lamborghini while I'm still trying to learn how to drive stick shift. It's
yeah,
like,
that's a great
wow, you
analogy.
could do so much. Where's first gear?
Yeah. So, I think it's definitely great to have like a more interactive thing. I just think it was uh like it's something that I was trying to incorporate, but it's hard like to involve like other like multiple students like doing like an interactive thing because
Oh yeah,
everyone
yeah,
kind of
yeah.
moves at their own
This is
pace.
just showing how powerful it is, and kind of for future reference, when I need that superpower, I'll go, oh, there was something about that.
Yeah, yeah. So I definitely appreciate you bringing this up because I think it is good to talk about like how um this is like more of a reference kind of thing and like showing you what like pandas or like NumPy or like later Matplotlib is capable of. But the best learning does come from just kind of like playing with it yourself. So I don't, yeah, I think like if the section leaders have maybe like a short exercise that they could find that like um is essentially just like a quiz of here's like here's a data frame, like how can we generate um like a third column to the data frame, like let's add or like
Yeah,
double it
so
or just like do operations on it.
Dieter gave a good reference. This was the reference I was going to make available if we didn't have this book. And so, I would check out that reference he put in the chat.
Yeah,
I'm
thanks
booking,
so much.
marking it now.
Yeah. So I think like a useful like plan would just be to like absorb as much of this as you can from like the reference material and just like me kind of trying to walk you through it and then seeing if you can apply that to some of these examples. Where like honestly, I'm sure there's plenty of things that can be found online that um, just like give you practice questions or like things that you can use to like play around with these libraries.
Yeah.
So yeah, thanks for the great question. I think it was definitely worth talking about. Cool. So yeah, I think that's it for data indexing and selection. Now we can go to the next chapter, which is operations and pandas. Um, and then I think, yeah, basically to just give you guys like a heads up for what more there is to cover. And to sort of answer your previous question, Vicky, the next chapter is on missing values. And I think that's like where I want to stop it for pandas. I think that's like um, a lot of good material already, like the fundamentals, if not like excessive, but that's like a good stopping point, I think, for this for pandas at least from this reference material. Um, so yeah, moving on to operations in pandas. So previously we saw like how to create series and data frames and how to like access or modify them. So now we're going to see how we can do like operations like basic arithmetic, as well as here like there's some more complicated stuff like trig functions and other like math functions. Um, so yeah, let's just start running through it. So again, we're going to start by importing both pandas and NumPy. Here we're creating a NumPy array of just of random numbers, and then we're going to create or sorry, this is like a random state. So that here, so see this, add a cell. This just tells us like gives us a random number generator that kind of follows a specific order using like the seed 42. So this just gives us like a panda series of randomly generated numbers. Um, so I believe this tells us we can do this again. It's because there's so many oops. There's so many things in NumPy that it's hard to remember everything, but I'm guessing this is just like from 0 to 10, we're generating four numbers. But you can see um, here that it tells us random is from low to high and then size. You can also specify data type, but that's defaulting to an int. So yeah, here we've generated these four numbers into a panda series. And then now we're also creating a data frame, which uses, I guess, a shape of 3 to 4, a two-dimensional NumPy array, converting that into a data frame where we have A, B, C, and D as columns. And then because we don't specify like the rows, this will use like the implicit 0, 1, and 2 as the row indexes. Um, let's see. We can also apply a NumPy ufunc on these objects. So exponent, what does this do actually? yeah, exponential of all the objects. Um, okay, it's just I guess E. So this is I guess like the exponential function on the series that we defined. Um, and then this gives us like I think this is like e to the 6, e to the 3, 7, and 4. So these are the values. You can see that it applied them to every single row, but it also preserved the indexes of 1, 2, and 3. So we're not like applying the exponential function on the indices as well, just the values. And then here, I guess we're doing like another set of mathematical operations, but this time on the data frame. So it's just doing like a bunch of stuff here. We're like multiplying by pi, dividing by 4, and then taking like the sign function of that result. Um, if yeah, and then this gives us like the values, so you can just see how that like corresponds to these. Yeah, so like 6 pi over 4, stuff like that. Um, yeah, so again, you can see that the indices are preserved as 0, 1, and 2, and the columns A, B, C, and D. The only things that are changed are the actual values. So it's nice that we can use like these NumPy functions on the pandas series of data frames. Yeah, and then we have index alignment. So let's create like these two series, area and population. We can see what each of them are. So area is Alaska, Texas, and California. And then population is like a slightly different set of indexes. So when we try to divide them, we get some not a number entries because they don't exist across both of the series. Um, so yeah, it says the resulting array contains the union of indices, which is just like all of the possible indices that exist. It's just that because like we involved both of them for Alaska and New York, which only existed in one or the other, we weren't able to generate like a um, division result, which is why it showed not a number. But this will show. What does it say? Interesting. We'll just skip over that. I'm pretty sure this is supposed to just show us the determine using the union of the two. So it should show us like Alaska, California, New York, and Texas. Um, yeah, let's ignore that in my live demo. Um, so moving on, we have two more series that we're defining with specific like indexes. So you can see like A, we're defining with indexes 0, 1, and 2, which is pretty much similar to like pretty much just like the implicit indices. And then we have B is defined as 1, 2, and 3. So when we add them, we get like not a number for 0 because 0 index only exists in A. Not a number for 3 because 3 only exists in B. And we only add 1 and 2 because those are the only indexes that exist within both. But this seems like pretty illogical because maybe that just means like the 0 index for B is 0 and the 3 index for A is also 0. So what we can do to um, like accommodate for that is to add like this argument in the add function, which allows us to treat those values as 0. Um, yeah. More index alignment. Let's see. We have A and B are two data frames that we're creating using the series have like the implicit indexes. And then if we try to do an operation on them, um, then A plus B will, let's see. Yeah, so C doesn't exist across both of them, and then the second index doesn't exist across both of them. So we'll only perform the operation where there's like a complete overlap in the indexes. Yeah, here this is essentially yeah, a dot stack dot mean gives us like the mean. Let's see what fill is. So that's like 12.25. So that just gives us the mean of all the rows in A, sorry, yeah, the rows in the column A. And then now we can use that value as like the fill value to populate like the not a number columns. Yeah. And then this just tells us like the equivalent pandas methods for specific Python operators. So you can always like fill in some fill value if there's like not a complete overlap in the indexes. Um, and that helps with alignment. Yeah, and then lastly, there's operations between data frames and series. Um, Here, let's create these. Um, yeah, this is a NumPy array. And then if we do a minus a0, so when we subtract like a NumPy array to a scalar, it does it for all of them. So we're just subtracting um, oh, a0. We're subtracting like the entire row from each of the rows. So sorry, that's not a scalar. This is a NumPy array since it's two-dimensional. And then we can do a similar thing in pandas. So here we have like a data frame. It's pretty similar to like a 2D NumPy array. So if we just show like what data frame looks like, it's this. And then if we subtract like, so this is index location of 0, this will give us like this first row. So when we do that subtraction, it should give us like, I guess it uses the same values here, and it will give us the same results. Um, so yes. Yeah, you can also, there's like a lot of ways you can play around with it. So here we're doing like operations row wise, but if you want to use column wise, you can actually specify the axis. So for NumPy, uh, that kind of like does rotates like for the R column, it like does the same subtraction across all the columns instead of doing a subtraction for all the rows. And then the equivalent for data frames is this this axis pattern, which is a bit confusing. But this just means like the zeroth uh, element of the data frame for um, the yeah, wait, zeroth element for every other. Yeah, let's actually see what this is. QNS. Okay, yeah, so it's every other. Yeah, so this is like the row, and then this is the column. So if we look at data frame, we got a cell here. You see that like this 0 corresponds to like this row, and then this tells us like we're doing every basically selecting everything, but like skip every other column. So we start with Q, and then we skip R, we go to S. So that's what like this 2 means. That's like the step. And then because we're selecting just the first row, we're selecting 7 and 2. And then when we subtract the half row, this gives us this. Basically, we're only subtracting for columns Q and S. And the not a number comes from the fact that these columns don't exist in half row. So we have to do index alignment. And the index alignment can be something like what we saw earlier, where we were doing like a fill value. So if we did like maybe what was this? Pandas or data frame dot subtract. See its sub, and we can subtract half row where the fill value is maybe like, let's say 0. No, value 1. No. Let's see if we do this and subtract. Yeah, this is the problem with ambition during live demos. Fill value. Let's see what the error was. That's it. Yeah, I don't want to waste your time. But yeah, this is let's just do data frame minus half row. Leave it at that. Um and yeah, if section leaders want to help me, that's okay too. I don't want to do debugging like during the session. But yeah, any questions with that? Feel free to drop a comment. I see someone asked, I'm having trouble understanding half row. I can talk about that a little like one more time. So the I guess let me see if I can go back to data indexing, where we talked about iLove. See if they I guess it may not have been covered, but here we can play around with it. So data is a series. Maybe we have to do um, data frame. So this I think I skipped over, so that's my bad. But we can do like we can use for using iLook on data frames. Um, we can actually pass in multiple values. So let's see, data here. Again, we're gonna have like this table, area, population, density, and then when we do iLook, so let me add one more cell here. This first one will reference like uh, the 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 rows. So this should give us like the first 3 rows, 0, 1 to 2. And then the second one references like the columns. So this should give us area and population. So this is kind of just like we can support up to 2, I guess, because like Pandas data frame is 2-dimensional. But we'll support like indexing based on like each dimension, and each dimension is separated by a comma. So here, like :3 is, think of it as like if we were to just look at like uh, one series, like if we said like data area, and we wanted to access like the first 3, this would give us California, Texas, and New York. So this is like where that um, :3 like gives us the first 3. And then I think what do we have? Yeah, we had :2 for the columns. So that's more similar to like given like one specific row, so like all of the values of California, um, querying like the first 2 columns, so area and population are the first 2. Yeah, so going back to half row, um, this now we can think of like this first number or this first index as the row index, and then the one after the comma as the column index. We can think of it as like 0 tells us we're looking at just the first row, and then ::2 tells us that we're looking at out of the columns, we're looking at every like from all the columns, but with a step of 2. So we start at Q and we want to step 1, 2 to S, and that gives us it. So if we wanted like maybe from, so this is kind of like a syntax that you're probably familiar with from Python lists. It's just like usually not separated by commas. But if we wanted to do like from R, S, and T, which is like from 1 to 4, then this would give us like the latter 3 columns, or even we can omit the 4 to be like we want everything but the first, or yeah, but the 0th column. So this will give us R, S, and T, and the 0th index of all of them. Hopefully that answers your question. And yeah, if anyone else had any questions, feel free to add them to the chat. So real quick, I want to go over this last chapter, handling missing data, and then we can take a quick break before Matplotlib, which I think should be fairly quick. But yeah, we've noticed that like a lot of times data frames can have missing data, like the not a numbers that we've seen in our table. So far, we've just seen it as a result of uh, like mismatched index, so like index alignment. Um, but here it says like the real world data is rarely clean and homogeneous. So we definitely have to think about like how to handle missing data when we're using data frames, because realistically, like not all data is going to have every column and every row completely populated. Um, so yeah, there's like a couple ways to handle missing data, and we can just kind of go through like some examples of them, and hopefully like this makes it kind of applicable to um, or like logically applicable to real world data that like isn't always homogeneous. But here we're like just manually defining the data like a NumPy array with missing data. Here data type is object, because like we mentioned before, um, we are finding like that common umbrella type that we can use for everything in the NumPy array, because the NumPy array is homogeneous. And then yeah, for data type and object int, I guess this is just telling us like objects are a lot less efficient than integers. Yeah, while that runs, yeah, you can see that int is like, I think this is microseconds and this is milliseconds, so it's just a lot faster. Um, the use of Python objects in an array also means if you perform aggregations, yeah, you'll get an error. So because it's an object, you can't sum it. Cool. Missing numerical data. So instead of using none, we can use not a number. So this allows us to keep the data type as a float, or I guess like a number. Here we're using a float because that's just like a specific quality of NumPy. So because the data type is not an object, we can perform like arithmetic on it without like it completely erroring out. But yeah, it infects any other object that it touches. So this is all not a number. Yeah. And then I guess um that affects like the default sum, min, and max. But NumPy has its own functions that are able to avoid it. So when we use nan sum, um, we get um, like 8 for all the values summed together. You get 1 and 4 for the min and the max. So that's um, missing missing data in NumPy. And then now I guess Pandas is able to handle both of them interchangeably. They just treat both of them as not number. And then we can define a series and set one of them to none. And that would still treat it as not number. Um, yeah, these are just like, I guess, specific nuances for how Pandas treats uh, like, yeah, missing data. Um, cool. And then now here's some functions that Panda uses uh, that we can use to handle null values. Um, so going through each of them one by one, we have is null. That's like it generates a Boolean mask, which we talked about earlier, is like just a series, or it could be a data frame of just like true or false, which we can use to apply to like retrieval and like indexing data selection. We have not null, which is the opposite of is null. It generates like the reverse Boolean mask. Um, drop NA filters out the null values, and then fill NA returns a copy with the missing values filled. So let's try each of them. So we'll have data. This is going to look like, I guess, just an object where we have a bunch of different values, and then is null will treat uh, not a number and none both as null, but anything else as a regular, like not null. So then we can use not null or is null as like a mask. So when we try to access data, this will give us all of the values that are not null. You can also use is null similarly, but this just gives us all the values that are null. Yeah. Now let's see how drop NA works. This just deletes the null rows. So this actually gives us the same result as like if we were to access um, the data that was not null. But it actually modifies it. Actually, I don't think it does. Yeah. So it gives us the same result as that. And then yeah, for data frame, there's more options. So let's create a data frame. It's a bunch of null values we can see. But since it's two-dimensional, you can't drop single values. You can only drop like either the entire column or the entire row. Just because of, I guess, like how the two-dimensional thing like fundamentally works. Um, like if you drop one, then you have to drop everything in either that row or the column. So at default, drop NA drops all the rows. So here we see that row 0 and row 2 both have null values. So we're just going to drop them entirely. But if you want to drop instead the columns, then we get to keep column 2 because these null values exist in columns 0 and 1. But yeah, the problem here is that it can drop good data as well because these columns or these rows have non-null values. So we can kind of like tune these a bit to work according to how we want it to. So yeah, how equals any means that any row or column containing a null value will be dropped.
Hello?
You can also
Hi, it's your own guest doctor from the ICU. How are you?
Hi. This is Vicky. How are you?
Hi Vicky, I think you're
Oh,
not
oh,
muted.
hold on. Sorry. Okay.
Okay, you're good. Sorry. Anyways, we have where was I? Yeah, the how argument to the drop NA. If you specify any, it will perform the way that we just saw it. If you specify all, then you'll only drop it if they're all null. So I guess here we're modifying or adding like a new column to the data frame where all of the values in the series are null. So drop NA when how equals all will only drop the column that's entirely null. Um, and then if we remove this, it goes back to any, and then it will only drop a row if, um, or it will drop a row if they're all, if there's any, sorry, drop the column if there's any null values, but if we change this to row, sorry, that's what I meant. Yeah, rows, then it's not going to drop anything because there aren't any rows that are entirely null. And then, yeah, here we have even a finer grained control. You can actually choose how many non-null values it takes for it to drop the row. So here, like the threshold is 3. You need like at least 3 non-null values. Otherwise, the row gets dropped. Yeah, and then we have finding null values. I think that's about it. Or sorry, filling. So here, let's quickly just make the series. We have like 2 null values, and then we'll fill the null values with 0. So sometimes this can be useful if you want to like treat missing data as just like 0, which is common for like some integers. Forward fill propagates the previous value forward. So what that means is just like it uses the prior value. Yeah, so here we had like 1 in A. Since B was null, it just takes the value of A. It will just find like the most recent non-null value and propagate it. And then backfill is the opposite, essentially. And then here's what it looks like on data frames. So like you can see these null values were filled, forward filled. So they just found like the previous value. So these were replicated as 2, 5, and 6. And then this one was replicated as 1. But because this this null value didn't have a previous value, it stays as null. Cool. Any questions? That'll be it for pandas. Um, let's take like maybe a 2-minute break, and then we can go into Matplotlib. This one will just have like two two chapters ish, so it shouldn't take too long. Yeah, let's get started at 40, 43, the minute 43. All right. Um, let's get started with Matplotlib. This is essentially just a visualization tool that builds off of NumPy, and since NumPy is very similar to Pandas, you can also use it with Pandas. Um, so here we'll have to uh, import Matplotlib. So I recommend running the cell just to see if you have it installed. If not, the installation process is the same as Pandas in NumPy, just using um, pip or um, Python-mpip, or however you've been using to install that. Um, so yeah, just make sure you're able to import it. If it doesn't work, then it should show an error here. Yeah, we'll just run through this. So we have plot.style that use classic. This just uses the classic matplotlib style. Feel free to kind of like look up the documentation for this and play around with it. I think this is just like an aesthetic choice. Um, so yeah, just moving on slowly. Plot.show will show plot. So this is an example. We have like a NumPy array, and then we're plotting the values against sine and cosine. So then when we run, it says like plot.show, and then if you run it in the, if you have this in a file and you run that file, it should show the plot. But we can actually plot it just directly from our Python notebook. So we can say matplotlib inline, which will allow us to use static images of our plots instead of interactive ones. So we're gonna actually take like the same example from earlier and run that code. So here we can see like we're actually able to plot sine and cosine on the graph. So if we go say plot.plot, question this, it will show like here we're adding like each of the arguments means this the argument, so x is like the one axis and then cosine is the other axis. And then this third argument is, let's say somewhere like, the line. So line properties. Um, yeah, I'm not going to comb through it here, but the documentation should outline like what this means. But I mean, we can see that the result of the plot shows that like one is a solid line and one is the dotted line. So this is what the plot looks like. And we can just do that pretty easily by just saying like plot dot plot. There's also this where you can save the figure to like a file in your working directory. And then I guess this just shows that it exists in the current working directory. And then you can actually just like display it. But this is using not matplotlib, but just like displaying the image. But that's just to show that you can save the file. Um,
Hey Chris, once you
yeah,
generate that figure in like a Jupyter notebook, okay, if you want to like download it for like publication, put it into like a paper or something, how would you do that?
yeah. So that's using the save figure that we saw.
Oh,
So
okay.
I guess this these like series of cells is just to prove that like the figure was properly saved.
I
But
see.
if you go to like your Jupyter like file tree, you can see that like I just created this figure. I don't know if Jupyter, yeah, Jupyter can actually open it. So this is what like that figure looks like in Jupyter.
Um, okay,
Um,
and then if
yeah.
you want to like adjust the size of that, how would you do that?
I'm sure there's ways that you can do it directly with Matplotlib. I don't know off the top of my head, but you can always like resize it like the way you resize regular images as well. It's like not really a special image, it just downloads like the graph as a PNG.
Hmm.
So there's like image editing tools like Microsoft Paint that you could use. But I'm sure there's also ways that you can do it with Matplotlib directly. I just don't know off the top of my head.
Okay.
Um, that's like a fun exercise that maybe people can try. Just Googling like through the Matplotlib documentation. Um, yeah, and then can skip over this maybe. Um, if people are familiar with MATLAB, maybe this will help. I'm personally not, but um, this kind of syntax is, I guess, similar to MATLAB syntax. Um, but yeah, subplot just kind of allows us to, instead of overlay the two, um, provide them like on top of each other or side by side. And then there's object-oriented interface. Um, so this is like another way to create that graph. Two subplots and then call plot on each individual subplot. There's a lot of like configuration that you can do, but the primary thing to know is that plot just takes in like um, your your data. So X is like essentially just like a long NumPy array of numbers. And we can see that like X is just basically like um, a very long NumPy array that just stores like increments from 0 to 10. And then when we call NumPy dot sign of X, it shows like the value of the function applied to each individual value of X. So then when we plot them against each other, this is essentially what like sine and cosine look like. Um, yeah. And then the rest of it is mostly like formatting things. So like what we saw earlier, which I wasn't able to get the documentation for, but if we like wanted to maybe make it like a dashed line, let's see if this works. Yeah, so this like gives us a dashed line. So things like that. So that's the intro to Matplotlib. There's a lot more you can do with it. You don't always have to create like a line graph. So I guess here we'll start with like line plots. Let's see. Clear outputs. We do all of the setup that we usually do. No, this is not supported. So let's just do classic. And then start by creating a figure and an axis. This is our like blank slate. And then you can actually do plotting on that. So this gives us like the sine function. Um, yeah, and these are just like an alternative way. You want to create a single figure with multiple lines, you can call it multiple times. So that's what we saw in the last chapter, anyways. This is like just aesthetic purposes. You can do a lot with like colors. So here we just have a bunch of different like sine of x minus 0, x minus 1, so on, and they're all colored differently. So this gives us like this nicely colored graph where all the sine functions are shifted by a little bit and changed color. Um, it looks like, yeah, let's see. Yeah, it looks like if there's two different plots, it will choose different colors. So I think Matplotlib just, yeah, default cycles through them. But you can also use line style, which is what we saw earlier, with just without the line style equals specified as the argument. Um, but this just shows like a lot of different ways you can choose like how your line looks. And I guess you can combine them to change the color and like the line style. So these are just ways to play around with it. Um, and then you can also notice that I guess X just went from 0 to 10. So when we ran the previous plot, it ended at 10. But if you wanted to extend the limits of the X and the Y axis, you can actually specify that. But because our data only exists within the bounds of 0 to 10, like this is what that graph would look like. Um, yeah. And then plot.axis is just like a shorthand way of saying the same thing as this. Um, as the above, I guess. This is if you want to reverse the axes. This is just like extraordinarily confusing, but you can do it if you want. So now 0 is on the right and 10 is on the left. Um, and negative 1.2 is on the top and 1.2 positive on the bottom. Just to show that like you can do it if you wanted to. Yeah, and then there's a couple more ways you can use axis. Tightens the bounds, and then equal. Um, what does this do? Equal aspect ratio on your screen. So 1 unit of X is 1 unit of Y. Um, yeah. Yeah, and then some other things you can do just like because um, generating the images is like pretty like generating these images like you want to have a lot of flexibility. Like you can add titles similar to just like if you're generating like a plot in Excel, you can add all these things as well. So if we wanted to say like X label is X, Y label is sine of X, and then the title is a sine curve, you can do that. You can also just add a legend by getting plot. Um, yeah, there's a bunch of like customizations you can make to your graph using Matplotlib. Um, and then Matplotlib gotchas. Um, I think yeah, we can probably skip over that. Um, yeah, and then lastly, I want to go over this simple scatter plot one, just because it's slightly different from the line plots that we've used. Um, so running through this again, classic. Um, we can see that you can actually use like the same format or the same function to produce like scatter plots. So it's the only difference we've seen here is like the O indicates that the scatter plot. Um, so yeah, I guess this tells us like what all the different markers are. So O corresponds to like a dot, but we have all these other markers that we can use, O, period, comma, and so on. So this allows us to add variety to our graph. Um, yeah, and then this is like a combination of a line and a scatter plot, so on. So yeah, this is like the default plot, and then you can also use just run this just to show you. You can also use scatter, which is pretty much similar to the plot where you set the marker to one of the plot points. Um, yeah, the primary difference is you can use scatter plots where the property of each individual point can be individually controlled. Um, something like this. Um, so yeah, I think at this point, like you kind of get the idea where like matplotlib is pretty standard. Like most of the case, you'll be calling plot.plot or plot.scatter. And then there's just like a ton of customizations you can do to it. This one like uses random numbers. I guess the random state is the same, but if we like change the random state, then it will generate like slightly differently, and so on. So like there's just I guess like a lot of customizations you can make to the graph, basically. And we'll just run through each of these. I don't have sklearn, so that's why this is not running. But if you want to install sklearn using pip, um, that should work. But yeah, that's pretty much it for Matplotlib. It's pretty straightforward if you just want to graph like a regular looking graph. But as you can see, like it gets pretty complicated if you want to make something like pretty. Um, but that's just a matter of like playing with it and like figuring things out the same way like you do any other graph in like Excel or however people used to create graphs. But yeah, any questions about Matplotlib?
It's going to be fun to give it a try.
Yeah, it's definitely cool because you can kind of directly see the visual effects of like whatever you changed. And it's much better to like see that visualization of it instead of just like a long list of numbers, which is what we've been looking at before.
Yeah,
So something that would be fun to play around with.
cool. Thank you.
Yep, of course. Um, is this a hand raised from Lucia? Yeah.
Yes, I couldn't access MATLAB. Can you show me how to access it? I don't know if I have it on my Python
Sure,
yet.
sure. So do you have the Jupyter notebook open? Like, are you on a like this similar chapter?
Yeah.
So if you don't have Matplotlib, when you run this first cell, is there like an error that shows up?
I wasn't running um, in the same place, and then I was using a different line to start that one.
Sorry, could you repeat that? I didn't catch that super clearly.
I that I didn't see this import line when you explain. So I
Oh,
was
you
using
didn't
a
see the
different.
import? Oh,
No, because I didn't have.
so
I had
mhm.
Jupyter open, but I didn't have the handbook.
Oh, I see, I see. So are you just like typing along in your own Jupyter notebook? Sorry, I think your mic is a bit hard to hear, but if the case is that you don't have Matplotlib installed, then you can type like you can open your terminal and type pip install this or something similar. Yeah, hopefully that helps.
Okay,
Any
thank you.
other last questions? If not, I think we're out of time. Thanks everyone for tuning in.
Thanks, Chris. Thanks, everyone. Just last reminder, okay, I'm still missing a couple surveys until that magic number of 20. So if you want the video, please fill out